All right, so the first example we're going to do of showing a limit doesn't exist is going to be, let's see, here we go. We're going to show that this limit as x and y go to 0, together the origin, that x squared times y over x to the 4th plus y squared, and we want to show that limit does not exist. So remember, my steps are going to be to pick two different paths, evaluate the limit, and then show that I got different numbers from those two different paths. And so my first path, I'm just going to take a generic y equals mx. If you don't like that, you can just pick any number you want. You could say that's y equals 4x and go ahead with it. So my limit for xy going to 0, 0 of x squared y over x to the 4th plus y squared is going to just become my limit as only x goes to 0, because I'm going to get rid of all my y's. And everywhere I see y, I'm going to replace with mx. So let me do some like underlines so you can see that's what I did. Actually, I'll do it here too. And I can go ahead and simplify that. X going to 0 of x squared times mx is just mx cubed over x to the 4th plus mx quantity squared is x to the 4th plus m squared x squared. And I could go ahead and pull out a common factor of x squared everywhere. Oops. So my limit as x goes to 0 of m, I'll put it up front here. I'm going to pull out one of my x squared there, mx. I guess that simplification was unnecessary. Then I've got this x squared. My x to the 4th becomes x squared. My m squared x squared just becomes plus m squared. And then those two x squared cancel out. So I'm looking at the limit as x goes to, to 0 of mx over x to the 4th plus m. Awesome. No, we're not going to write on that line. Mx over x to the 4th plus m. So that's my m can come out front. Limit as x goes to 0, x over x to the 4th plus m. That's m times 0 over m. That's just 0. And I get that that first limit is 0. And then I repeat the whole thing for a different path. This time I'm going to take y equal to x squared. And my xy going to 0, 0 is going to be x squared y over x to the 4th plus y squared right there. Again, it's just going to turn into the limit as x goes to 0. And now everywhere I see y, I'm going to replace with my second path relationship given by x squared. It should be about the right place. All right, so x squared times y becomes x squared times x squared over x to the 4th plus y squared becomes x squared squared. So I've got the limit as x goes to 0 of x to the 4th over x to the 4th plus x squared squared is x to the 4th. or the limit as x goes to 0 of x to the fourth over 2x to the fourth. Those x to the fourths are going to cancel out. Oh, actually, I don't need my limit anymore. Those cancel out, and that's just equal to 1/2. And now I can say that the limit doesn't exist, DNE, because I got along one path a limit of 1/2, and along another path a limit of 0. And since that can happen, I know that I couldn't possibly find a single limit for this point. And that's going to be the approach we take. Real quick, since I didn't go as long as I thought I would, I just want to point out that you could do this with any path you want. These are not the only two paths that would work out. They're just sort of like convenient paths because things cancel out. Maybe if you had done y equals 4x, you would have thought, next I'll try y equals 5x. That would have been a bad move because my m's canceled out. They didn't matter. So in general, if you do something and it doesn't depend on like the number you plugged in to your path, don't try that path again. And you should be okay.